Hi, I'm Kyla James, and in this video, we're going to learn about probability distributions. The first thing you need to know in order to understand probability distributions is what a random variable is. Now, a random variable is a variable that represents a numerical value associated with each possible outcome of a probability distribution. It is denoted by the letter x. Examples of this would be X is the number of sales calls a salesperson makes in one day. And another example is X is the number of hours spent on sales calls in one day. There are two types of random variables. The first one is a discrete random variable. The discrete random variable has a finite and countable number of outcomes that can be listed. Keyword there is countable. Recall our example earlier. Which among the two do you think is a discrete random variable? The first example or the second example? Which among these two examples can be counted? Therefore, the first example is the discrete random variable because x represents the number of sales calls a salesperson makes in one day. This means that it can be counted either there are 0 calls in a day, or 1, or 2, or 3 calls, or 4 calls, or 5, and so on. The next type of random variable is the continuous random variable. The continuous random variable has an uncountable number of outcomes, and it can be represented by an interval on the number line. So since the first example earlier was a discrete random variable, this goes to show that the second example is actually a continuous random variable. The number of hours you spend on sales calls on a day can either be in the interval between 0 to 24 hours. You can't count it. It is in this interval only. It can be either be 2 hours spent, or 3 hours, or 24 hours, and so on. The interval is 0 to 24 hours. In order to distinguish between these two types of variables, you only need to remember these two words. One is that the discrete random variable can be counted. Remember, discrete is counted. Meanwhile, the continuous random variable is measured because it is in an interval. Therefore, it is measured. Variables that can be counted are discrete, and variables that are measured are continuous. So let's proceed to these exercises in order for you to master how to distinguish between the two variables. So given this example 1.2, let X represent the number of Fortune 500 companies that lost money during the previous year. Is X a discrete random variable, or is it continuous? Can X be counted or measured? Yes, since X can be counted, this is a discrete random variable. Let's proceed to example 1.3. Let X represent the volume of gasoline in a 21-gallon tank. Is this a discrete random variable or a continuous random variable? Can X be counted or is X measured? Now here X represents volume, and volume can be measured. Therefore, X is a continuous random variable. X can be in the interval 0 to 21. Since you've mastered and understood what a random variable is, it's now time to proceed to knowing about discrete probability distributions. A discrete probability distribution is a list of all the values the discrete random variable can take along with its probability. There are two conditions you must take into account when making a discrete probability distribution. The first condition is that the probability of each value of the discrete random variable is between 0 and 1 inclusive. The second is that the sum of all those probabilities must be equal to 1. So, how does one construct a discrete probability distribution? There are 4 simple steps. So let X be a discrete random variable with the possible values x sub 1, x sub 2, x sub 3, and so on. The first step is that you should make a frequency distribution of all the possible outcomes. Second, sum it all up. Third, Find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. And lastly, check if the conditions are met, which is 1, the value of the probabilities are between 0 and 1 inclusive, and the second one is that the probabilities all sum up into 1. Now observe this example. You are tasked to construct a discrete probability distribution and make a graph. Remember the 4 steps. So the first thing you do is make the frequency distribution of each possible outcome. It is already given in the problem that there are 150 employees. This means that the total of the frequencies would also be 150. So the next step would be finding the probability of each possible outcome by dividing its frequency over the total frequencies. And this is how you do it. The next step is that you should check if these values or if this probability distribution satisfies those 2 conditions that I've mentioned earlier. Do all the probabilities satisfy the first condition? Yes, it is between 0 and 1. Next, what is the sum of all these probabilities? It is equal to 1. Therefore, this is a discrete probability distribution. And when you express this through a bar graph, this is what it looks like. So in verifying whether a probability distribution is a discrete probability distribution or not, is that you only need to check the 2 conditions, or you only need to check if those 2 conditions are satisfied. Always remember those 2 conditions. So, given this probability distribution, is it a discrete probability distribution or not? The first step is checking if the probabilities are between 0 and 1, and that is satisfied. Next, you have to sum it all up and see if it equals to 1. So, this is a discrete probability distribution. Next, given this example, is this a discrete probability distribution or not? First, check if all the probabilities are between 0 and 1. That condition is satisfied. Next, you have to sum all these probabilities up. Is it equal to 1? No, it is greater than 1, right? Therefore, this is not a discrete probability distribution. Next, you are given this example. First, check if condition number 1 is satisfied. You can see that one of the probabilities is 5/4 and the other is negative, and another one is -1. From that, you can see that it is not between 0 and 1. Therefore, this is not a discrete probability distribution. Now that you've mastered that and can now determine whether a distribution is a discrete probability distribution or not, it's time to learn about the mean of a discrete probability distribution. In order to solve for the mean of a discrete probability distribution, each value of x is multiplied by its corresponding probability, and all these products are added up. That is your mean. We call the discrete probability distribution for the personality inventory test. Find the mean score. So this is the discrete probability distribution. Observe the third column. In order to solve for the mean, you must multiply the value of x by its corresponding probability. So 1 times 0.16 equals 0.16. 2 times 0.22 equals 0.44. 3 times 0.28 equals 0.84. 4 times 0.20 equals 0.80. And 5 times 0.14 equals 0.70. Remember that the mean is the sum of all the values of the third column. So when you sum that all up, so 0.16 plus 0.44 plus 0.84 plus 0.80 plus 0.70 equals 2.94, and that is approximately equal to 2.9. The mean score is slightly less than 3. This means that the mean personality trait is neither extremely aggressive nor extremely passive, but slightly closer to passive. After you've learned how to solve the mean score, it's time to learn about the variance and the standard deviation. In order to solve for these two, you are given these formulas. Notice that the standard deviation is the square root of the variance. So find the variance and standard deviation of the probability distribution for the personality inventory test for passive-aggressive traits. Recall that the mean score for this probability distribution is 2.94. Observe the third column. Subtract the mean from the value of x. So 1 minus 2.94 equals negative 1.94. 2 minus 2.94 equals negative 0.94. 3 minus 2.94 equals 0.06. 4 minus 2.94 equals 1.06. 5 minus 2.94 equals 2.06. In the fourth column, you simply square the values found in the third column. So negative 1.94 squared equals 3.764. Negative 0.94 squared is equal to 0.8884. 0.06 squared equals 0.004. 1.06 squared equals 1.124. And lastly, 2.06 squared is equal to 4.244. In the last column, you multiply the values found in the fourth column by its corresponding probability. So 3.764 times 0.16 equals 0.602. 0.884 times 0.22 equals 0.194. 0.044 times 0.28 equals 0.001. 1.124 times 0.20 equals 0.225. And 4.224 times 0.14 equals 0.594. In order to find the variance, you must add all the values up found in the fifth column. So 0.602 plus 0.194 plus 0.001 plus 0.225 plus 0.594 is equal to 1.614. This is your variance. Note that the standard deviation is the square root of the variance. So you only need to find the square root of 1.1614, which is approximately equal to 1.3. Lastly, you need to know about the expected value of a probability distribution. The expected value is simply equal to the mean of a discrete probability distribution, which means it is the summation of all the values of x multiplied by its corresponding probability. Now, given this example, find the expected value and interpret its meaning. The first step is that you must find how much you can gain for each prize. The first step is you need to find out how much you can gain from each prize. Recall that the price of the ticket is $2. So, subtract 500 minus 2, which is equal to 498. 250 minus 2 is equal to 248. 150 minus 2 is equal to 148. And 75 minus 2 is equal to 73. And there's the instance when you don't gain a prize, which that would be equal to 0 minus 2 because you bought that ticket at the price of $2, which would be equal to negative 2. Next, shown here is the discrete probability distribution for each gain or outcome. Now you should find the mean. So simply multiply each value of x by its corresponding probability and find the sum of all these products. And that would equal to negative 1.35. This means that you should expect to lose an average of $1.35 each time you buy a ticket. That would be all for this video, and I hope you learned something. Thank you.